This week's lesson still uses Turtle as a base, but we will look at variables, strings, lists, integers and split arguments. At the heart of this lesson is how to troubleshoot, how to plan and how to know what end result you are after. So this week we will see the process I went through to embellish a block of code and tailor it to meet my intended aims, complete with setbacks and triumphs. So let's get right into it. This block of code here was my starting point. By now you should recognise this block of Turtle code. In the books I am reading, there is a section of one chapter that talks about one variable to rule them all, and that got me thinking. The end result was cool, but the programmer had to set the variables, not the end user. I wanted to create a user interface to this code. The aim of the interface would be to allow any user to input their own colour choices, set the number of sides, the length and the angle and so on. Doing this would, I reasoned, be more engaging to the end user, who would be active and not passive in the code. I had seen elsewhere in the book that the t.input argument prompted a response from the user from within the Python shell, but I did not want that. I wanted a text box to automatically pop up in the Turtle screen when the program ran, so I continued my hunt. What I found was the turtle.textinput argument. This is really cool. I knew immediately this is what I wanted and so wrote the following code. Before we examine what I wrote, let's look at how the text input brackets have to work. Inside the brackets you can see that I have strings. There are two of them and both are essential to get the text box to work. I tried it with just one string and I got an error message that said it needed two arguments. The first string labels the window, the second string contains the user instruction for the input window. So now I had my input device. I reasoned that it would be a simple case of creating a variable that equaled the content written by the user input. My col variable would be decided by user input, and so would all the other variables in this example. So I went straight ahead and wrote the code you see here. I created the variables that would be populated by my text input trick, and then the variables were put into the code. When I ran my code, it utterly failed. This was a good thing, as it taught me a really good lesson. When coding, take baby steps and test each new element individually and not as a whole, as it makes debugging harder. So I simplified my code as you can see here. I decided to just focus on two user inputs, the colour and the number of sides of the shape. When I ran my code, I got the following error message. String object cannot be interpreted as an integer. That told me that my colour argument had worked, but that my sides argument had failed. It also taught me that I'd made assumptions about how the text input argument works. I'd assumed that any input would be interpreted by Python in the manner of the input. In other words, if the text is text, then use it as a string. But if the input is a number, recognise it as such and use it as a number. But that's not how the text box works. Any input by the end user into a text box using the text input argument is treated as a string by Python. I guess that if I'd sat and thought about the name of the argument for a moment, I would have realised this from its name. My next goal was to find out how I could have an input box that allowed Python to recognise the numbers input were to be used as integers, whole numbers, and not as strings, text. I found this additional argument, int, for integer or whole number. I then put the text input argument inside the int brackets, taking care to ensure that all opened brackets were then closed. See the end double brackets here. What the int argument does is it tells Python to recognise the number input via the text box as an integer and not as a text string. Once it does this, the conditions for the sides variable can now be met, and so the user of the code can pick their own colour and number of sides. I tested the code with green and 5 and got this result. By not trying to create one huge solution but breaking the desired end result into smaller steps, I quickly started to get the results I wanted. Take heed. This is a valuable lesson to learn. Know your endpoint, break the problem into smaller steps, test each step, use the error messages to help provide clues, and test, test, test. So, to recap, variables can be populated with content via text boxes, which allows users to input stuff. By default, all text input, including numbers, is treated as a string by Python. So the int argument needs to be used where you want to have a number used by Python to do some form of calculation. Now that I had solved this problem, I could now move on to my more ambitious program. What I now wanted was for users to input a range of colours so that I could have them create content similar to the outputs we created in Lesson 2, where we used the mod operator to count through the colours and change them in sequence. To do this, I changed my colour text box instructions to encourage the user to add multiple colours, separated by a comma. My thinking here was, and again it turned into an assumption, was that the comma would indicate to Python that the text in between the commas would be a string. When I ran the program, I got the error message from the turtle shell that I'd created a bad colour string. Clearly my assumption was just that. I needed to find a way of being able to create a list from a multiple string input in a text box. After some research on the internet, the books did not seem to cover the avenues of inquiry I have chosen to go down this week. I found that I could indeed create a list for my col variable by adding an additional argument to my text input argument, by adding the .split argument. What Python does is add the commas between the words and treats each word as a separate string, and therefore builds a list for my colours. By adding this additional argument, I was able to then test my program by making a triangle with 3 colours, all chosen through the text input user interface, and this is the end result. Having cracked that nut, I now wanted to go the distance and start to play with the range element of the for_x in range statement. My first idea was to simply use the length variable and multiply this by 2.5 to get a large enough repeat value. However, when I did this, I got the following error message. Float object cannot be interpreted as an integer. If I'd chosen a whole number to multiply my length by, my code may have worked. But because I had used a decimal number and a number harvested from the int argument, I had clearly set up a contradiction. Hitting this problem made me think about adding another variable that would allow me to put an appropriate integer into the range brackets that would satisfy Python. By creating the repeat variable, the user is now able to input all of the variables into my program so they have complete control over the output of the shape that they create. I had met my goal, and the end result from that was this shape. You can clearly see that I was able to determine the colours of the shape in a repeating pattern thanks to the string created through the .split argument. I was able to create integer-based variables using the int argument, and all of these variables in their turn satisfy the conditions needed to allow the modulo argument to work in the pen colour statement. In short, it worked. But let's reflect on how it worked. I started with an endpoint in mind. I had a clear vision of what it was I was trying to create. In the first instance, I thought that I had found a one-size-fits-all solution to my problem and applied that to the entire program, thinking that would be the answer. It did not work. Python's error codes seem to make no sense at all, but if you read and consider what the error says, it tells you where it fails on what line. This is a clue. By looking at the error message Python is saying, up until this point all was fine. This helped me to zero in on my own errors. An error message in the shell that says line 8 in module t.pencolor bad color string tells me that the previous 7 lines were okay, and the error lies in the text string. What works is this. Have a clear success outcome in mind, build a simplified version of what you hope to achieve, then add one new element at a time, test the changes. If they work, great. If not, use the error reports to help you work out what you need to add. StackOverload.com is a great place to go to search for solutions. So on to this week's challenge. As we have played with variables this week, I am starting to see the power of them as well as the power of the user input via the text input argument. So this week's challenge is not necessarily a turtle challenge. In my mind, I am seeing a game. At this stage it would be a simple guess my number game. This is something that at this stage would only have one answer. So here are the parameters of this very simple game. For the moment, I think it will be fine if this entire game runs in the Python shell. Using variables, can you create a variable called answer that has a set value? At this stage, the value of the answer has to be between 0 and 10. Using either the input or the text input arguments, can you create a user input request that asks the user to guess the number? Once they input their guess, Python has to evaluate the number, so the int argument might be key here. To evaluate the answer, the if argument will have to be used. We've not covered this, so you might have to do some research. But what we want to happen is for Python to do something like this. If the answer is wrong, return a prompt that says wrong answer, please try again. If the answer is correct, then Python says correct, you win, and stops the game. I am sure that over time we can embellish this game, but for now this will do. So remember, keep it simple, test it, and keep practicing!